Well, we've got a really fun topic today, one that has always been near and dear to my heart, one that I've always enjoyed. Now, you're probably thinking, as elite Algebra 2 students, I already know everything there is to know about parallel and perpendicular lines, and hopefully you do. And we're just going to tap the brakes a little bit. We're going to continue to strengthen that foundation, make sure there's no cracks or crevices in that foundation so that we can build up to bigger and bigger bears. But I think I would be shocked if you didn't learn one or two new little things before this video is over. So let's go ahead and dive in. What are we going to get into? So first of all, we're going to look at, can you write the equation of a line that's passing through a given point and who is parallel to another equation, okay? Then we'll do something similar here with perpendicular. Can you take an equation, find his slope, and then tell us what the slope of any perpendicular line would be? And working our way up to this idea of, can we write the equation of a line that passes through this point and happens to be perpendicular to this equation? So hopefully that doesn't sound too overwhelming. Let's dive in and take a look at what parallel lines really, really are. And this is going to be, some very official lingo here, but I think it's going to help. So if you have two non-intersecting lines, those lines lie in the same plane and they are parallel to each other. Just picture two long railroad tracks side by side. Now, if those two lines do not intersect, basically what we know is that the ratio of the line's vertical change compared to its horizontal change is the same for each line. Now, that's a really complicated way of saying what? These two lines have the same slope, and that's what we're getting at. Parallel lines have the same steepness. They must have the same slope, and that's what you'll continue to hear us preach over and over again. In a nutshell, m sub 1 equals m sub 2. The slope of the first line must equal the slope of the second line. So we'll sneak right into this first example here. One other thing I'd like to add here. So as soon as I see this opening phrase, when he said write the equation of a line, I'm already thinking y minus y1 equals m quantity x minus x1. Okay, I'm already thinking that. So I just got to get my hands on my slope and a point that line passes through, and we are golden. So what do we got cooking here? Our line's got to be parallel to this one. Now this guy has a slope of 2. Therefore, the slope of my line also has to be 2. We've got our point. I think we're off to the races. Y minus 5 equals 2 times the quantity x plus 4. We got it. Now, if you wanted to, you could solve for y if you wanted to. We could distribute the 2 to make 2x plus 8 and then add the 5 over to make 13. But a lot of times that's an optional move, and we'll have to read the directions to see how far they want us to go. All right, graduating from parallel to perpendicular lines. It's going to get a little more intense now. So if we have two non-vertical lines that are perpendicular, then the product of their slopes is going to be -1. Now, that's maybe something you haven't heard before. Their product has to be -1. In other words, what we're really saying is that their slopes are negative reciprocals of each other, which is probably the way you've heard it said before. So let's just review that for a second. Let's say I had a slope, and my first line was, we'll just say A over B for a slope. Now, if they're going to be perpendicular, the slope of the second line has to be negative B over A. Now, you'll notice when I go to multiply those two slopes together, their product is -1 when you're all said and done. So that's just a neat thing about any number multiplied by its negative reciprocal, the product is guaranteed to be -1. And I never really took the time to try to visualize what that meant, but I think this picture does a pretty good job. So I think you'd agree that the blue line and the red line are perpendicular. They meet at a 90-degree angle. So how does this whole idea of a negative reciprocal really work? So what you'll notice is, let's do this. The rise for the blue line is the same as the run for the red line, right? And then, let's switch colors real quick. The run for the blue line is the same as the rise for the red line. The only exception is, one of them is going to be negated relative to the other one. So the rise of one is equal to the run of the other and vice versa. Boom, 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 boom. Okay. Again, find the slope of any line that's perpendicular to this line. The challenge now is I've got to be able to solve for y. So I'm just going to rewrite this equation, kind of get it in the center of my screen. And if I'm going to solve for y, I'm going to subtract an x from both sides. And I think I'm comfortable adding the 8 over at the same time. I'm going to try to kill two birds with one stone. So if I cancel those bears and cancel those bears, I'm going to get 4y equals negative x plus 8. Now what I'm going to do is I'm going to divide every term by 4. And y equals negative 1/4 x plus 2. So the slope of that line is going to be negative 1/4. Anything perpendicular to that would be positive 4, because 4 is the opposite or negative reciprocal of negative 1/4. Are we on fire or what? All right, I think this is the last one. So we want to write the equation of a line that passes through this bear. And again, let me say this. Do you see right out of the gates there, they said, write the equation of a line. So I'm automatically thinking what? Y minus y1 equals m quantity x minus x1. So I don't want to take that for granted. I always want to plant that seed as soon as I can. So again, I think I'm going to try to split my workload in half. Can I find the slope of this line first? 2x minus 3y plus 12 equals 0. I think I'm going to subtract 2x and subtract a 12 from both sides if I can squeeze it in here. And those bears cancel, and I get negative 3y equals negative 2x minus 12. Now let's try dividing everybody by negative 3, shall we? What is this going to look like when it cleans up? We sure got our handful of negatives, don't we? That's going to be positive 2/3 now, thank goodness, plus 4, because a negative divided by a negative makes a positive. So if the slope of that first line is equal to 2/3, then the slope of the line that I'm going to write is going to be negative 3/2, because it's the negative reciprocal. And then just take advantage of that point they gave you. So I'm thinking y plus 5 equals negative 3/2 quantity x minus 3. And I'll tell you what, I'm really not interested in solving for y if I don't have to in this case, because, distributing that fraction and such is probably not the most inviting thing. So hope you had fun today talking about parallel and perpendicular lines. They're not too bad. Just remember, parallel lines have the same slope, and perpendicular lines have slopes that are negative reciprocals, and you're going to be in great shape.